Hi everyone, welcome to today's lecture on composite materials. Today we are going to see characteristics and applications of carbon fibers and also about Kevlar fibers, their brief introduction, preparation, properties and applications. Now let's start our class with characteristics of carbon fibers. Characteristics of carbon fibers. The following are the characteristics of a carbon fiber. First one, physical strength, specific toughness, lightweight. And second, high dimensional stability, low coefficient of thermal expansion and low abrasion. Good vibration damping, strength and toughness. Okay, and the next we have electrical conductivity, biological inertness and X-ray permeability, fatigue resistance, self-lubrication and high damping, chemical inertness, high corrosion resistance. And last is electromagnetic properties. Okay, now the next we have here is about applications of carbon fibers. Let us dig deep into them. Here, as we have already seen various characteristics of carbon fibers, now we will try to list out all the applications based on each and every characteristic of carbon fiber. The first characteristic of carbon fiber in our list is physical strength, specific toughness, lightweight. And now the applications related to these properties are aerospace, road, marine and transport and sporting goods. Okay. The second characteristic of carbon fiber in our list is high dimensional stability, low coefficient of thermal expansion and low abrasion. And the applications related to these properties are missiles, aircraft brakes, aerospace antenna and support structures, large telescopes, optical waves with optical benches, waveguides for stable high frequency precision measurement frames. Okay, the next one, the next property of our carbon fiber in the list is good vibration damping, strength and toughness. And the applications related to these properties are audio equipment, loudspeakers for hi-fi equipment, pickup arms, robot arms, etc. Okay. Now, in the next in our list, the fourth characteristic of a carbon fiber in our list is electrical conductivity. And the applications which are related to these properties are automobile hoods, novel tooling, casings and bases for electronic equipments, EMI and RF shielding, brushes. Okay, next, the fifth characteristic of carbon fiber in our list is biological inertness and X-ray permeability. And the applications related to this particular characteristic or to this particular properties of carbon fiber are medical applications in prosthetics. Spelling is written wrong here. It's prosthetics, right? It's an ideal case things. Okay, surgeries and X-ray equipments, implants, tendon or ligament repairs. Okay. Now next. The sixth characteristic of carbon fiber in our list is fatigue resistance, self-lubrication, high damping, and the applications related to these properties or characteristics are textile machinery and general engineering. Okay, the last but one, that is the seventh characteristic of a carbon fiber in our list is chemical inertness, high corrosion resistance, and the applications related to these properties are chemical industries, nuclear fields, valves, seals and pump components in process. Finally, the eighth characteristic, the last characteristic of a carbon fiber in our list is electromagnetic properties, and the applications related to these properties are large generator retaining rings, radiological equipment. Okay, next, the future of carbon fibers. The future. The latest development in carbon fiber technology is tiny carbon tubes, which are called as nanotubes. These hollow tubes, some as small as 0.001 mm in diameter, have unique mechanical and electrical properties that may be useful in making new high-to-strength ratio fibers. Submicroscopic test tubes, or possibly new semiconductor materials for integrated circuits, as I have shown here. Okay, different new semiconductor materials. Fine, nice. Now, since we are done with carbon fibers, let us see about the next type of fiber in our list, that is Kevlar fibers. Under these Kevlar fibers, we are going to cover the following topics, namely, what is Kevlar or what is Kevlar fiber? What is the manufacturing process of Kevlar fiber, melt spinning process under it, all the mechanical properties related to it, and the applications of Kevlar fibers. And under these applications, we are also going to see few most important applications like Kevlar strings, Kevlar tires, Kevlar suit, and so on. Okay, now let's start discussion about Kevlar fibers. The most important question that comes into mind is, what is Kevlar in the field? Do you know what is DuPont? DuPont introduced the first organic fiber with high strength and aramid fiber with trade name called as Kevlar 29 in early 1970s. It was originally developed to replace steel in radial tires and known to have tensile strength 5 times more than steel. The invention enabled to fabricate flexible bulletproof body armor, right? Okay. In 1988, the second generation of Kevlar fiber was developed, which offers ballistic resistance against 9mm FMJ. What is FMJ? It stands for full metal jackets. Okay, moving on to the next slide. Kevlar is commercially available aramid fiber with excellent heat resistance and high stiffness related to other aramid variants like Nomex is a flame resistant meta-aramid material developed in the early 1960s by DuPont and first marketed in 1967. DuPont first developed Kevlar fiber in 1970 for their use in racing tires as a replacement of steel. It is commonly available in grades like K29, 49, 100, 119 and K129. Okay. Presently, Kevlar fiber is available in a number of variants like Kevlar K29. It is a high toughness grade used in industrial applications such as cables, body or vehicle armors, brake linings. The next is Kevlar K49. It has a high modulus used in rope and cable products. The next is K100, the colored version of Kevlar. Kevlar K119. It has high elongation and more fatigue resistance. And Kevlar K129. It is a higher tenacity grade utilized in ballistic applications. And the last one is Kevlar AP. It has about 15% higher tensile strength when compared to K29. Okay. Kevlar is a polypara phenyl iterate phthalimide, which is PPDT, commonly known as para-aramid. The structure is composed of benzene rings, which are responsible for high thermal stability, along with para substitutions, which result in high modulus and strength. The filaments for the fibers are extruded through the spinning of precursor. Right? The extruded rod-like para-aramid structure has high anisotropic properties. The strength and stiffness is higher in the axial direction and lowers in the transverse direction. Okay, moving on to the next slide. The manufacturing process of Kevlar fibers. Kevlar is made from a condensation reaction of 1/4 paraphenyl idiamine and terephthalic acid. The presence of amine groups on aromatic ring results in a rod-like structure which has high glass transition temperature and low solubility. The chains of polymer are connected to each other via hydrogen bonding between adjacent polar amide groups. The fiber structure is consisting of orderly oriented molecules parallel to one another, forming crystalline structures. Okay, moving on to the next slide. Due to high glass transition temperature and poor solubility, these fibers are difficult to process via conventional drawing techniques. Hence, melt spinning is used for their fabrication. And during this melt spinning, the PPDT solution is extruded in a spinneret and drawn through an air gap, resulting in the orientation of the liquid crystalline domains in the flow direction. The polymer chains also align in a fiber axis, resulting in a high degree of anisotropy in this direction. Melt spinning process fibers, here under this, the fibers are manufactured by melt spinning of PPDT solution, extruded through a spinneret and then directly solidification upon cooling. The solution is heated to attain required viscosity in induction heated extruders. This melt is passed at high pressure at constant rate from a spinneret and enters an air-cooled stream which solidifies it into a filament form. At the lower end of the spinning setup, a guided coverage converts these individual filaments to form a continuous spun yarn. This yarn is then wound onto bobbins or treated further for end-use applications. Okay, moving on to the next slide. The mechanical properties. Kevlar fibers have tensile strength twice than nylon, which is ranging from 2.6 gigapascals to 4.1 gigapascals. The mechanical properties of different grades are given or showcased in the tabular column here. As we can see here, that the comparison is made between three different grades of Kevlar fibers. The first being Kevlar 29, the second being Kevlar 49, and the third being Kevlar 149. The densities of all the respective grades as projected here in this tabular column are 1.44 grams per centimeter cube and 1.47 grams per centimeter cube. That means the densities of all the three types of Kevlar fibers are approximately the same, but the tensile modulus are observed. When they are observed, we can understand that the modulus of 29 grade Kevlar fiber is the least with 83 gigapascals, and the tensile modulus of 149 grade Kevlar fiber is the highest with 186 gigapascals, while that of 49 grade Kevlar fiber is intermittent with 131 gigapascals. Similarly, the tensile strength is also showcased as 3.6 gigapascals for 29 grade, 3.6 and 3.4 gigapascals for the other two. Kevlar fibers, okay. Finally, the percentage of elongation is about 4% for 29 grade, 2.8% for 49 grade, and 2% for 149 grades. That means 149 grade Kevlar fiber is less prone to elongation under tensile forces. Okay, next, moving on to next slide. The structure of Kevlar has unique kink bands. What are kink bands? They are understood to be an important mechanism in fiber failure under curvature. They form as a molecular chains within the fiber slip against each other under a compressive load, and these are responsible for the compression buckling of molecules, and hence they behave elastically under tension. In compression, they yield at 0.3% to 0.5% strain and shows non-linear and ductile behaviors. Okay, right. The high thermal stability attributed to aromatic rings makes these fibers inherently flame resistant with a decomposition temperature of about 425 degrees centigrades and are inherently flame resistant. The generic properties of these fibers are high tenacity, high modulus of rigidity, which is also called as structural rigidity, and the continuation of the list is low ductility, low electrical conductivity, low coefficient of thermal expansion, right? And the next one is high toughness, which is also said to be like work to break ratio, and high chemical resistance, excellent dimensional stabilities, flame retardant, and self-extinguishing. Okay, the next we have in the list is the applications. Okay, now in this slide we are going to see what are the different applications of Kevlar fibers. The exceptional and unique properties of fiber enable them to apply in a variety of applications. These applications range from premium sport goods and deep sea umbilical lines to high performance structural composites in aircraft components, boat hulls, and high performance cars. The high tenacity and thermally stable fibers are used for lightweight bulletproof body armor, and also due to weight saving it can also replace heavier metals in airplanes for fuel saving. The textile application was explored by Baxter, who is a textile engineer graduate of Clemson University, who fabricated a dragon jeans using 100% Kevlar in denim jeans. The variety of applications, there are a variety of applications which are as listed below here, like a ballistic and defense. Next is composites in aircraft and structural parts. Third is belt and hoses for automotive heating or cooling systems. The fourth is fiber optics and electromechanical cables. The next is friction products and gaskets. Okay. We also have few more in this particular list as projected here in this particular slide, like adhesives and sealants. The last is protective apparel in automobile and aircrafts. Okay, right. Kevlar strings. This is one of the really important applications of Kevlar fibers. In tennis strings, the high durability is considered a primary factor for consideration. I mean, it's a primary factor of consideration. Kevlar grade 16, 17 and 18 are primary grades which are used for making Kevlar strings. Polyester has slowly replaced the Kevlar strings due to better strength and durability, but that's a different scenario. Okay, now the next application, Kevlar tires. It is also a very important application. In fast racing cars and bikes, excessive friction on tires causes burning and overheating. The tire is composed of steel wires wrapped in rubber. These steel wires are insufficient to absorb all the heat. That's the reason material challenges come up at high speed. And therefore Kevlar is since a good heat resistant material with this ability to work in high tension situations. Nowadays, racing car tires have Kevlar as their essential ingredient while getting manufactured. Now the last, Kevlar suit. Bulletproof vests are the most common application of Kevlar suits. Bullets are small metal parts that penetrate the body due to their high speed and design. But in Kevlar suits, all the layers are threaded tightly together. These threads absorb the kinetic energy of bullets, which lowers the ability of a bullet to penetrate the body. Without sufficient penetration power, the bullets become harmless. Okay, fine. So with this, the topic of Kevlar fibers is done, and in the next session, in the next class, we will see what is a boron fiber, what are the different characteristics of a boron fiber, what are the different preparational methods, and what will be the applications of boron fibers, and we will also see the differences between glass fiber, Kevlar fiber, carbon fiber, and a boron fiber if possible. Okay, so with this I'm going to take a leave, and let's meet in the next class. Thank you.